Cool. All right. Hey, guys. I'm Hart from across. Going to give a talk that's a little bit of a refresh of what I gave at ETHCC. This is my take on why intents will win and how I think this intent architecture is a necessary component for us solving fragmentation across this many-chain ecosystem we're heading into. And it actually plays nicely off of the talk we just saw. I think a lot of the hot takes on chains becoming commodities are kind of true. Okay, so I'm just going to start from the beginning of what do we want here? We want cheap, fast, and secure interop that is so seamless you don't even know that you're talking to blockchains. You want it to just feel like one network, and my mental model is the user's just clicking buttons. They're clicking buttons, and those buttons are doing what they want to do. And I think it's worth remembering that we are building for users here ultimately, and that's all the user wants to do is click buttons on a website, and it does the thing they expect it to do. And when people think about connecting blockchains, the common design pattern they default to is something like TCP/IP. Is we have servers, they're connected to cables, and those cables send messages to each other. And my take is this is the wrong architecture for a blockchain. We'll go into this. Okay, so traditional approach. Bridging is sending a message. Blockchain A, blockchain B. I can't hold my hand out there. A and B. And I want to send value between these two chains. What do? I send a deposit transaction to blockchain A. I wait for a sense of finality. We'll come back to this in a second. I wait for some sense of finality on blockchain A. I send a message then, after I get that finality, to blockchain B. I release the assets. That seems problematic because it's, well, for a few reasons. This is impossible to do quickly, cheaply, and securely. And I'll walk through these three vectors, but let's start with speed. Most obviously, I have to wait for a sense of finality, and I have to wait for a message to get sent. And so our solution and the general approach of intents is simply stop sending messages. That is just going to slow you down. And what gets us here is this core observation that TCP/IP is about moving bespoke bytes. I'm sending a message across a network. And it's just the way that those messages are non-fungible. They're specific to what message I'm trying to send between two computers. Blockchains, however, are mostly about moving value. Not exclusively. There are times when I want to send a non-fungible or bespoke message, but most of the time I'm moving value or moving value plus some instruction of what I want to do. And this observation is kind of key here because value is fungible. It doesn't matter whether I get exactly that dollar from over there, over here. I just care about getting a dollar. And with that observation, you can kind of think, okay, wait, there's this other architecture where I can lean into the fungibility of money, the fungibility of value, to have very, very fast and seamless interop. And to me, that's how we arrive at intents. So what's this look like? Blockchain A, blockchain B. And instead of sending a message between the two, I'm going to use a third-party network of solvers, relayers, market makers, same term, same idea. I'm going to use a network of third-party actors that are going to observe the deposit transaction on blockchain A, and they're going to fund the user's fill with their own money on blockchain B. And they do this without waiting for a message to get sent between the two chains. Instead, those third-party observers are going to observe the deposit transaction, and when they think there's enough sense of finality, they're going to race to compete the user on blockchain B and fill the user with their own funds. This can be I'm saying what we do here. Yeah, solvers fill users with their own capital quickly and cheaply, and they get repaid later. Just dwelling on this point, we go back here. this can be extremely fast. We'll go into the three ways of why I think this is the better architecture. But speed here is what I think is most important from a user's perspective, because we're not waiting for any, finality risk is being offloaded to these solvers, and they can fill users extremely quickly. If I had my computer in front of me, I'd do a demo. I don't know if you guys have used Across, but you can move money between major blockchains in 2 seconds. Our median fill time right now between L2s is about 3 seconds, and it's getting faster. And we're getting extremely, extremely fast at our ability to move funds between blockchains while keeping it really cheap. So if you guys haven't done it, go to Across.2, try the demo. It works pretty well. Okay, so because you guys are all technical, we'll go a little bit deeper in the architecture here. I don't know if I have a laser pointer. No. But okay, 3 layers. The way I think of the intent architecture, it's 3 layers of a cake. We're going to have the intent layer, which is where the user inputs what they want to do. I want to move from A to B. I want to move 1 ETH from A to B. Maybe I want to move 1 ETH from A to B and buy an NFT, but I want to move money between 2 chains. We then have our solvers compete to fill them. This is the third-party network that is using their own capital to fill that user intent really quickly and cheaply. And then we have the settlement layer, where user assets are escrowed, and they're only released to the solver after we verify the intent gets paid. From a user's perspective, they only care about the first 2 layers because they're going to get filled quickly by the solvers, and then they go on with their day. Our solvers are the ones that care about ultimately getting paid back from this loan they've extended to the users. So they care about a robust settlement layer that will escrow user funds and is guaranteed to pay the solver back when they do properly fill an intent. Okay, so my argument here that intents can be really fast. And here's some data. I'm comparing ourselves to Circle's CCTP protocol and Stargate V2 bus and taxi. And our median fill time for L2 to L2 transactions, 3 seconds on this slide. And that's again because all the solver has to do is observe the deposit transaction on the origin chain, and then they're racing to compete them on the destination. And the other messaging-based architectures, kind of the traditional bridging architecture, simply cannot compete with that for core architecture reasons. You need to wait for finality on the origin chain or for a sense of finality, so you simply cannot do a 3-second fill. Otherwise, your protocol can't handle that. Here, the twist, the change in logic, is that we offload that finality risk to the solvers themselves. And those solvers themselves, as individual entities, they can price and kind of take on that finality risk that a protocol simply cannot. A protocol can't fail in that same way, whereas a solver can actually take on statistical risk about whether there will be a reorg on the origin chain. Okay. Advantage number 2 over intents, they can be really secure. Why? Well, the observation that we've made is this intent architecture separates 2 components. It separates the urgent part of the user requiring a fast fill from the complex part of sending a message between blockchains. And in this, by separating those 2 things, we can fill the user really quickly because the solvers are doing that with their own money and their own view that yes, this deposit on the origin chain did happen. But then because we have time to pay the solver back, we can use the most robust or secure messaging technique to verify that the intent was in fact filled. So Across fills users really quickly, and then we use a combination of an optimistic batching logic and canonical message bridges to verify those intents were fulfilled and do that complex part relatively slowly, but in a very secure way. And you can think about, again, the complex part. You can use any type of kind of cross-chain messaging or proving systems, ZK proofs, canonical bridges, optimistic systems. Do whatever you want to maximize security here. All right, And then this is where it gets spicy. Like, intents can also be really cheap. And I want to make sure, okay, tracking on time. We'll go in more detail on the next slide on kind of like my theoretical model for why intents can be so cheap. But the observation here is that we are minimizing messaging by batching the verification of intents. And this batch verification has very, very real cost savings. Simply put, if I have to send a message for every single cross-chain transaction, I'm going to be sending, in the world that we're going to see, billions of cross-chain messages. Maybe, but that sounds expensive. If instead I can have these intents that effectively batch and commoditize messaging, I can send far, far fewer messages to fulfill the same number of cross-chain transactions. And this batching gives us very significant cost savings. I'm not going to say that we're always the cheapest. There's heavy competition in this space. But I will say that for small volume transactions, we are the cheapest because of gas efficiencies and various other things. And I think we are the most scalable by far. So here's my model. And I actually, yeah, the argument here is in the across an intent-based architecture, I have relayers extending loans. These are short-term loans, about an hour. You could imagine this coming down in time. But in this example, I'm saying, theoretically, I do 50 million bucks of volume, and I extend a loan at 10% for an hour. A 10% annualized rate for an hour is a $500 fee. It's not much. And if I can prove that those 50,000 intents were filled with like 10 messages, and let's say I pay 10 cents per message there, that cost me $1 in messaging plus a $500 loan cost. It cost me 501 bucks, just as a theoretical example. Whereas if I'm sending 50,000 messages and I'm paying 10 cents a message to send those 50,000 messages alone, it's going to cost me 5,000 bucks. I just have a lot of messaging costs. So this is the sort of theoretical argument as to why the batching that Intents offers, even though there's this added cost of a loan where you have to pay solvers for their cost of capital, this is a theoretical argument as to why the batching can reduce our messaging costs and actually make the Intents architecture long-term cheaper. And I think this slide went up and people, some of our competitors, the Stargate guys, didn't like this. This is a theoretical argument, right? But we're walking through, I stand by this design pattern of messaging, if secure, will be expensive. And if you can reduce messaging by orders of magnitude, you will save money in the long run. So that's the spicy take. Related argument, Intents on small size, we actually move USDC cheaper than Circle does with CCTP. Why is that? Well, that's because we're able to have very lightweight gas costs and, again, batch messaging costs here. And so we're amortizing the cost of the message, the expensive part, over many, many, many transactions, which allows us to be cheaper than even like the native or canonical bridge of a native issuer. This isn't necessarily always true. It's going to depend on like the overall cost of gas, but I think the argument holds and makes for a strong point. Okay, so my argument, my TLDR, is Across can scale to transfer billions of dollars a day, and Across, I don't want to push us too hard. Intents can scale to transfer billions of dollars a day while sending very few messages because of batching. Non-intent designs would need to send millions and millions of messages to transfer $1 billion a day. You guys can think through what you think will cost less in aggregate. Okay, so what's Across doing here? Our vision. There's the intent layer where you're initiating the order. So we want to help aggregators, dApps, wallets create and route intents. That's just the sort of user input component. We have a solver layer where we're working, and we'll go into this in a second, we're working to establish a standard for what cross-chain intent looks like so that we can have solvers adopt this unified standard, which will just deepen liquidity for this pool of solvers. And then we have our settlement layer, which is where user assets are escrowed and only released to solvers after we verify the intent was fulfilled. Okay. So that's kind of what I think the stack, the interop stack in an intent-centric world looks like. And we've launched across V3. I'm just doing a time check here. Okay. We launched across V3 as this settlement system for cross-chain intents. Again, we're trying to live at, our goal with the protocol is to just make this happen. Early on in the history of Across, we ran solvers. We still do run one, but it's small. It doesn't do much volume now. We're just here trying to offer the best user experience through this. And Across V3 was trying to commoditize this intent-based architecture to let other applications, other solvers plug into this. And a big part of that was establishing this standard for cross-chain intents that we teamed up with Uniswap on. This is ERC-7683, which the Uniswap team has been very helpful in their input and development of and helping support. And our idea here is just, hey, this intent architecture makes sense. We want maximum liquidity at the solver layer. Uniswap agrees. Let's define a common standard that makes it easier for solvers to support any protocol or application that fits within this. And you guys shall go check out ERC-7683.org to read up more on what we're doing here. This is still a draft. We want feedback. But this is what we are directly integrating in our protocol and what we're working with Uniswap on. And people seem to like this. The Optimism Superchain, they're adopting this standard as well as a method for, and this has been announced, this is a method for them enabling fast interop between chains with an intent architecture that isn't protocol specific. So one of the other things that I care a lot about is if you're a chain or an application, you don't want vendor lock-in where you're unable to move off of or you're locked into the fate of your messaging protocol. So the Optimism team likes the idea of this standard being a way of supporting really fast interop with a great user experience without deep vendor lock-in to a specific protocol. And so we've been working with them to make this standard part of how native superchain interop will be really fast. And we keep adding chains. So we're 13 chains now, 10 more in the pipeline. We're trying to accelerate the number of chains we add here. Again, I think this is going to rapidly accelerate as chains become app-specific and specialize. And we want to be positioned to offer a super elegant interop experience between them such that it feels like one cohesive network. It's just one blockchain that you're clicking through is what the user experience should feel like. And we're also doing more and more, this animation didn't load, but we're doing more and more to make it easy to integrate across into your app with an SDK and API that makes it easy to have intent-specific architecture, allow you to have your app usable from any chain. That's our vision and focus here. And just a fun fact, Denkun with blobs, it's made L2s really cheap. We've seen volumes go up a lot. One of the things that I think was super cool is the average transaction size going between blockchains dropped by like an order of magnitude with Denkun. And it's simply a reflection of you make things cheaper, you get more smaller volume transactions and more users using them. And so data like this makes me super bullish on our multi-chain future and what we're doing to scale blockchains. And Across wants to be part of making this be a seamless experience. And I'll go through. That's it.